Welcome back. In this video we are going to discuss about probability, the subtopic of combined event, but for this one it is a worked example concerned with this subtopic. If it is a first time for you to watch my videos, hit the subscribe button below this video. Okay, let us go on. From the first question here, the question says that a die and coin are tossed simultaneously. Draw tree diagram and find probability of getting a head and a number less than 3. Okay, for this one we have solved like as follows. Okay, here we see that there is a die and a coin which is tossed simultaneously. So that means, for instance, this is a die. A die consists 6 elements. This one is a 1, 2, 3, 4, 5, 6 elements of the die. So here we have 1, 2, 3, 4, 5, 6. This is a die. But you say that a die and a coin are tossed simultaneously. So because there is a die and a coin here, so we have to introduce the coin. Coin consists head or tail. So head or tail. So head here or tail. The same to this one, head or tail. Head or tail. This one, head or tail. This is a coin, must have head or tail, like this one, head, tail, head here, tail here. Okay, from there supposed to write the set of some space here, in which the first set will be one head. The second set will be one tail. This one, one tail. After there, two head. This is 2 tail. This one 3 head. This one 3 tail. This one 4 head. This one 4 tail. This one will be 5 head. This one will be 5 tail. And this one is 6 head. This one is 6 tail. From there, this one as the element of a set of sample space, and this one is what we call the tree diagram. Okay, let us write the element of a set of sample space. Now this one will be like as follows. So element of set of sample space will be like as follows. What is the first one? The first one here is one head, then one tail. Okay, so here we have one head, one tail, then 2 head, 2 tail, then 3 head, 3 tail, 4 head, 4 tail, 5 head, 5 tail, 6 head, then 6 tail. This one will be the set of sample space. But how about the number of sample? You have to count how many elements in the set of sample space. Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of sample space here will be equals to 12 plus 12 here. Okay, so this one is a number of sample. In order to find the number of event, you're supposed to check what we're supposed to find here. Okay, let us review our question. From the question, we need to find probability of getting head and the number less than 3. So head and the number less than 3. So you have to check from the set of sample space, head and the number which is less than 3. Here we have head and 1. This is the head and the number which is less than 3. How about this one? Head and 2. Okay, this is head and the number less than 3. How about this one? Head and 3. This is head, but this number is not less than 3, so forget about this one. The same to this one. It is a head, but the number is not less than 3, so forget about this one. This one also forget about it, because this number is not less than 3. Even this one, this number is not less than 3. So number of event here, number of event, while my event is a head and the number less than 3 here, is only 1, 2. So is equal to 2. That means my number of event equals to 2. Then because this is a number of event and this is number of sample, I can find the probability of event by taking probability of event equals to number of event divided by number of sample. This one will be equals to number of event 2 divided by number of sample, it is 12, Now from there, by simplification, we'll find probability of event equals to 1 over 6. So I'm done for the first one. Okay, let us check the second question here. Okay, from this question, it said that a fraction is written by selecting the numerator from the digit this one, 1, 2, 3, and the denominator from the digit this one. Draw the tree diagram and find the probability of getting a probability that a fraction written is less than a half. So this fraction is written by taking the numerator from this digit 1, 2, 3, and the denominator from this digit. What does it mean? That means the numerator digit consists the following: 1, 2, 3. This is the numerator, and the denominator digit consists this one 6, and this one 8. But we know always fraction is written in form of numerator over denominator. So actually we're supposed to start with the numerator first, then denominator. That means we're supposed to present the numerator first, then we follow the denominator. Okay, let us present it. Now it will be like as follows. Okay, so now the first one, it's supposed to be numerator. This is the numerator: 1, 2, 3. 1 here, 2 here, 3. This is what we call a numerator: 1, 2, 3. But after there also we have a denominator. Our denominator is 6 and 8, don't forget. So will be 6 or 8. So this one 6 or 8. This one 6 or 8. Okay, this one is what we call denominator. So we have numerator here, and also we have denominator here. Okay, then from there my set of sample space will be like as for my first element will be 1 over 6. So 1 over 6 is our first fraction. Our second fraction here will be 1 over 8. So this is 1 over 8. For this one will be 2 over 6. 2 over 6. For this one will be 2 over 8. 2 over 8. This one is 3 over 6. 3 over 6. And this one will be 3 over 8. So this one will be the set of sample space, and the whole this one is what we call the tree diagram. Okay, let us write the set of sample space. Will be as follows. Okay, my set of sample space will consist of the following element. What is the first element? Is 1 over 6, then 1 over 8. Okay, now it is 1 over 6, 1 over 8. After there, 2 over 6, then 2 over 8. This one. After there, we have 3 over 6, then 3 over 8. This one will be the set of sample space. Then from there, we can find the number of sample space by counting them. How many elements in a set of sample space? When you count here, 1, 2, 3, 4, 5, 6. This means number of sample is supposed to be equals to 6. That means my number of sample here will be equals to 6. But how about number of event? I'm supposed to refer from the question. Let us check our question. What is the event? Our event here, is to find the probability that the fraction written is less than a half. So our event is a fraction which is less than a half. So from the set of sample space, you have to check which fraction is a less than a half. Okay, let us start from this one. Is it less than a half? Yes, this is less than a half. This 1 over 8, is it less than a half? Yes, it is less than a half. How about 2 over 6? Yes, less than a half. How about this one? Yes, it is less than a half. And how about this one, 3 over 6? Wow, this is not less than a half, because this is a half when you simplify. And how about this one? Also it is less than a half. So how many fractions are less than a half? We have the first one here, 1, 2, 3, 4, 5. That means number of event here is equal to 5, because there is 5 element which is less than a half. Okay, then from there I have number of sample, but also I have number of event. I think I can find probability by taking that probability of an event. This one equals to number of event divided by number of sample. That means this one will be equal to number of event 5 over number of sample 6. Therefore, probability of event will be equals to 5/6. I'm done for it. Okay, let us move. Now the question number 3. Okay, from this question, it says that in a family of 3 children, what is the probability that all are girls? For B, at least 2 are boys. Okay, the family have 3 children here. The family have 3 children. We know children, it can be either boy or girls. First case, we need to find the probability of all of them to be girls. Second one, find the probability that at least 2 are boys. Okay, let us move. For this question, we know there's 3 children. It means the first child, it can be either boy or girl. This is the first child. Let me write the first child. It can be either boy or girls. How about the second child? What is the second child? It can be either boy or girl. Either boy or girl. Boy or girl. This is the second child. But how about the third child? Because he says the family has 3 children. Okay, the third child also, it can be either boy or girl. Boy or girl. This one, boy or girl. Boy or girl. This one also, it can be either boy or girl. This one is a boy or girl. Okay, from there, this one will be the third child, like this one, third child. Okay, now I can find the set of sample space. Okay, my set of sample space consists of the following element. The first element, it can be boy, boy, boy. So boy, boy, boy. That is the first. The second one, it can be boy, boy, girl. This one, boy, boy, girl. Okay, then the third one, it will be boy, girl, boy. Yes, boy, girl, boy. Okay, after there, boy, girl, girl. Okay, boy, girl, girl. Then this one will be girl, boy, boy. Girl, boy, boy. Then will be girl, boy, girl. Girl, boy, girl. Then this one will be girl, girl, boy. Girl, girl, boy. Then the last one will be girl, girl, girl. This one, girl, girl, girl. Okay, from there, I'll find that the set of sample space will consist that elements. All of this is an element of the set of sample space, and this one is what we call the tree diagram. Okay, now we have to mention the element of the set of sample space. This will be as follows. So my set of sample space will consist of the following element. S will be equals to set of sample space. The first one is boy, boy, boy. All 3 to be boys. Or the second one, what is the second one? The second one will be, that is the first. Second one will be boy, boy, girl. Okay, boy, boy, girl. How about the third one? The third one, boy, girl, boy. Okay, boy, girl, boy. Then after that one, we have this one, boy, girl, girl. This one, boy, girl, girl. Then after that one, girl, boy, boy. Then we have girl, boy, boy. Then after there, we have this one, girl, boy, girl. We have girl, boy, girl. Then after there, we have girl, girl, boy. Okay, this one, girl, girl, boy. Then the final, we have 3 girls, girl, girl, girl. Okay, this one will be the set of sample space. What is the number of set? Number of sample space will be equals to, let us count. We have 1, 2, 3, 4, 5, 6, 7, 8. So number of sample here equals to 8. You have to write the number of sample equals to 8. Okay, but how about event? Number of event depends on the question. Let us refer from the question. The first one, we need to find probability of getting all are girls. So the first one, probability of getting all girls. So my event is all girls. Okay, from this set of sample space, you have to find where there is all girls. Okay, where there is all girls from this one. Okay, this one all boys, not one, but this one consists all girls. So this one, it consists all girls. For this one, no. This one, no. This one, no. This one, not, no. Okay, all girls, there is only one pair with the all girls. That means my event here, number of event equals to 1, because there is only one pair which consists all girls. Okay, that means number of event equals to 1, because my event is to find all girls, and here the pair which consists all girls is only one pair. That's why my number of event equals to 1. But remember, number of sample equals to 8. Then from there you have to find probability by taking probability of event equals to number of event divided by number of sample. From there we find this one equals to 1 over 8. That means the probability of event here will be equals to 1 over 8. I'm done for it. That is the A. But how about number B? Number B, you have to check its number of events. Okay, number B is at least 2 are boys. At least 2 are boys. Okay, so you have to check which element consists at least 2 boys. Okay, from this set of sample space, you have to check which element consists at least 2 boys. So you have to count at least 2 boys. Here we have 3 boys, so you can pick it because he said at least. So in case they are greater than 3, no problem. So at least 2 boys, this one I can pick. Also at least 2 boys, this one is at least 2 boys. This one at least 2 boys, yes, pick it. This one, no. At least 2 boys, this one, okay, you can pick at least 2 boys. This one, no. This one, no. This one, no. So at least 2 boys, it is only 1, 2, 3, 4. That means number of event here will be equals to 4. Okay, so let us write it. Number of event will be equals to 4. Then from there, for that case B, for this case B, number of event will be equal to 4. Okay, but don't forget our number of sample is equals to 8. Don't forget about it. So from there you have to proceed. Probability of event will be equals to number of event divided by number of sample. From there I'll find equals to 4 over 8. But that 4 over 8 will be equals to a half. Then probability of event will be equals to a half. So I'm done for it. Okay, let us shift again to the last question. Okay, for this question here, 3 coin are tossed simultaneously. We need to find probability of the following: 3 head to appear, 1 head to appear, 2 tail, and 1 head. Okay, for this question we have 2 attempts like as follows. Note that 3 coins are tossed simultaneously. It means you have the first cone, second cone, up to the third cone. All of these are tossed simultaneously. This one will be like as follows. Okay, 3 coins are tossed simultaneously. Okay, let us start with the first coin here. This is our first coin. It consists either head or tail. That is our first coin. It have either head or tail. Okay, this one will be the second coin. This one, second coin. It consists either head or tail. Head or tail. This is our second coin. Let us write here. This is the second. And also we have the third coin. It also consists either head or tail. Head or tail, like this. Head or tail. Head or tail. Then head or tail. Head or tail. This one also head or tail. This one is the third coin. Okay, so now we have the first coin here, we have the second coin, and this one is the third coin. Okay, let us write the set of sample space will consist of the following element. The first one will be head. The second one here will be heady, heady, tail. This one, heady, heady, tail. Then from there, the third one here will consist this one, heady, tail, heady, heady, tail, heady. Then this one will consist heady, heady, tail, heady, heady, tail. How about this one? Will consist tail, heady, heady, tail, heady, heady. Then from there, this one will consist tail, heady, tail, tail, heady, tail. Okay, this one will consist tail, tail, heady, tail, tail, heady. And the last one will consist tail, 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 tail. This one. Okay, now from there, this one is the element of a set of sample space, and from there, this one is what we call the tree diagram. Okay, let us write the set of sample space, which consists of the following elements. The first one is heady, 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 then heady, heady, tail. Okay, set of sample space will consist of the following. The first one, heady, heady, heady. The second one is heady, heady, tail. What is the third one? Let us refer the first one, the second one, the third one is heady, tail, heady, heady, tail, heady, heady, tail, heady. Then after there we have what? Heady, tail, head. Then heady, heady, tail. This one, heady, heady, tail. Then from there we have this one, tail, heady, heady, tail, heady, heady. Then we have tail, heady, tail, tail, heady, tail. After there we have tail, tail, heady. We have tail, tail, heady. Then the final, it is tail, 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 tail. Okay, this one will be the set of sample space. Because that is the set of sample space, I can say the number of sample space will be equals to element found in my set of sample space. So I have to count element in this set of sample space. I have 1, 2, 3, 4, 5, 6, 7, 8. So number of sample here is equal to 8. Let me write number of sample equals to 8. But how about event? I'm supposed to refer what I want to find. Okay, so for the first case, A, what I'm supposed to find? For the first one here, we need to find probability of getting 3 heady. So our event is 3 heady. Okay, where there is a 3 heady? Okay, let me check for the first one. It consists 3 heady. Where there is a 3 heady again? This one, no 3 head, no 3 heady, no 3 heady, no 3 head. So 3 heads, it exists only at the first part. So the element which consists 3 heads is only one element which consists 3 heads, which is this one. So the number of event in which my event is existence of 3 head is only 1, because there is only one element in a set of sample space which consists 3 heads. Okay, so from there, because this one is a number of event and we have number of sample, I can find the probability of event will be equals to number of event divided by number of sample. From there I will find number of event here is 1 over number of sample is 8. So this one will be the probability of an event for the case number A. Okay, let us shift to the case number B. For the case number B, what is the event for the case number B? You have to check what is the number of event for this case number B. You have to check the event in order to find the number of event. Okay, case number B, our event here is 1 heady to appear. Okay, so from set of sample space, how many elements consist 1 heady? Okay, from this one, element which consists 1 heady, this one doesn't consist 1 heady. Okay, this one, the first one doesn't consist 1 heady. Let us shift. The second one here doesn't consist 1 heady. This one doesn't consist 1 heady. This one, no, doesn't consist 1 heady. This one, no. And how about this one? This one, it consists 1 heady. Yes, this one, it consists only 1 heady. So you can pick the first element which consists 1 heady, After there, we have this one. Also, it consists one head. The second element here consists one head. Okay, there is another one which consists one head. No one which consists one head apart from this one. So we have only two elements which consist one head. The first one is here and the second one is here. So element which consists one head is only two, this one and this one. That's why the number of elements is supposed to be equals to 2. Okay, so for this one, number of elements equals to 2 because there's only two elements which consist one head. Okay, then from there, probability of event will be equals to number of events divided by number of sample. But our event is one head. The element which consists only one head is only 2. That's why number of event here equals to 2 over number of sample. Okay, what is number of sample? You have to refer. What is number of sample? Number of sample equals to 8. Okay, so this one will be equals to 2 over 8. But by simplification, probability of event here, you will find equals to 1 over 4, something like this. Okay, for the question number C, you have to know what is the number of event. In order to know the number of event here, we're supposed to check the event. Okay, what is the question number C? Event from the question number C. Question number C, refer from this one. Our event is 2 tail and 1 head. 2 tail and 1 head. Okay, so my event is 2 tail and 1 head. How many elements consist 2 tail and 1 head? So we have to refer 2 tail and 1 head from the set of sample space. From this set of sample space, what is a 2 tail and 1 head? Okay, 2 tail and 1 head. This one not 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 2 tail and 1 head. Okay, this one is a first element which consists 2 tail and 1 head. This one also consists 2 tail and 1 head. There's another one. No, this one is not 2 tail and 1 head. Not 2 tail and 1 head. So here we have only 2 elements which consist 2 tail and 1 head, which is this one and this one. That's why number of event also will be equals to 2. Okay, so there number of event equals to 2 because there's only 2 elements which consist 2 tail and 1 head. That's why number of event here equals to 2. And also don't forget our number of sample was equal to 8. Then from there I'm supposed to find probability of event by taking number of event divided by number of sample. From this one I'll find number of event equals to 2 over number of sample equals to 8. This one by simplification we'll find that probability of event here will be equals to 1 over 4. So I'm done for it. This one is the end of my presentation, but don't forget to subscribe to my YouTube channel by click the subscribe button below this video. Thank you.